obsessive compulsive disorder. And yeah, that's my problem. Okay, so we have, oh, it's in orange, sorry. So we have our MZ over here. Right, so we have our MZ. So because we know that this is going this way with right hand rule, so MZ, this side will be tensile. MZ, this will be in compression. And then if we look into MY, right? So this is our MY, right? So this is our, based on right hand rule, our vector. So our moment vector, bending moment vector. So this is MY compression, and then MY tensile. So I'm going to pick 4 points again. I'm going to pick 4 points. Okay, we are going to pick 4 points. So these 4 points, this point over here is alpha. This point over here is beta. And then over here, like last week, we call this I, right? And then we call this J. I like to be sure that we call this I and J last week. I think we did. Right, so if we look at here, so I labeled same, okay? So alpha, beta, I, and J, as you can see down there. So what we have here now, right? So we look at stress A, or stress at alpha, stress at beta, stress at point I, and stress at point J, right? So the first one we are going to look at is, if we are going to look at moment induced by Y, and then the next column is moment induced by moment induced by the Y axis, and then the next one is moment induced by the Z axis. Okay, so we look at this now. Oh, stupid thing, it always does that. Sorry. Right. So if you were to look at, right, moment, let's look at point alpha. Okay, let's focus on alpha point. Okay, alpha point, MY will be inducing what? Tensile, so it's positive. And MZ, right, as you can see down here, is going to be inducing a compression, negative. Then if we look at point beta, MY is going to induce a compression, and MZ is going to induce a compression. Okay, can someone tell me at point I, MY is going to induce a compression or tension? Anyone, please?
Tension.
Yes, you got it. And then MZ, if you look at MZ now at point I, we are looking at point I, MZ is going to be tension. And then if we look at point J, MY is going to induce a compression. And at MZ is going to induce a tension. So if you look at the direction of the moment inducing what? Stresses, we realize that point B has the maximum compression. And then we realize that point I has the maximum tensile, right? And then the rest, alpha and J, they will never be the same. Okay, they never be the same. They will never be the same at all. Okay, so this is what we classify as unsymmetrical bending. Based on what? Based on stress field again. Okay, based on unsymmetrical bending, right? So this is based on stress field. Now, some of you, or I have some student asking me, Eugene, those bloody arrows look confusing, right? So if you want to make those arrows easy for you, this is one of the things that I teach. Okay, if I'm going to teach a new principle, it has to be easy. So all you need to do is you draw your arrow, right? And then you draw an arrow like this, and then this will be compression, right? And this will be tensile. So the next thing that you do, if you are worried, or you're not sure which is compression, tensile, you just need to draw this, okay, and you copy and you paste, and then you rotate this by 90 degrees towards the left. Okay, so when the moment arrow is at that direction, okay, compression is on top, tensile is below. And I'll do it again. You paste, okay, then you rotate. I know you guys think that what the hell is he doing? Is he crazy or what? Okay, so you rotate again. So when the moment arrow is pointing downwards, compression and tension is that way. And then finally, it is done in the other direction. Okay. There you go. Does that make sense now? Okay, so if some of you are confused with right hand rule, don't be. Okay, you just draw this once, rotate it. Okay, like for this case. Okay, let's check. Moment about Y, you have compression on the right hand side, tension on the left hand side. So this is moment about Y. This is valid. Then you have moment about Z. Okay, so bottom is tensile compression, and on top is what? Compression. So it's valid. It's the same as this. Okay, so this is to help you so you'll be able to visualize which one is tension and which one is compression. Now, if we look at symmetrical, I want to bring us back full circle. If we look at symmetrical bending, okay, if we look at symmetrical bending, right? If we look at symmetrical bending, right? So if we look at now in symmetrical bending, how to identify symmetrical bending is this. I think you guys already know already. So in symmetrical bending, you only have a moment vector in one direction. So for this case, so I'm going to say our moment is at, right? So this is our only moment, right? You don't have, so in unsymmetrical bending, so moment or acting moment, you only have one acting moment only. Okay, so likewise. Okay, so again, if we were to call points alpha, beta, I, and J, right? So we will have moment about Z, right? So you have stress alpha, then you have stress beta, stress I, and stress J, and then you will have this in on top will be MZ compression, and then you will have MZ in tension, and they all share the same Y, right? So the Y, so this is your Y1, right? This is your Y1. Over here, this is your Y2. So you realize that alpha are both what? Compression, and they are both what? Tension. And happen to be stress I is equal to stress J. Stress alpha is equal to stress beta. This is where we classify this loading system based on stress field to be symmetrical loading. Okay. Right. Any questions so far, or we are okay? No question? Okay. So the next issue is this. Okay. The next issue is this. If we were to look back at the formula, right, you see that yeah, IYY IZZ, right? It is a very easy formula. You can see it's straightforward, but in order to do your analysis and to get your IYY IZZ correct, okay, it can be quite tricky. So how to know what is IYY or what is IZZ? Okay, so I'm going to teach you a simple way to remember this now. Okay, so we are going to look at, I'm going to draw a structure, still rectangular. So again, we have our transformation. Okay, so this is our transformation. And then this is our y-axis. And this is our z-axis. And then I'm going to have specific distances. So this will be my B from here to here. All right, so this will be my B. And then the next one, this will be my D. Those are my dimensions, right? So I'm going to copy this whole diagram. I'm going to paste. Right, I'm going to ask all of you again. Right, so on the left-hand side of the diagram, I want to calculate what is my IYY. And on my right-hand side, I'm going to calculate what is my IZZ. Okay. So can anyone tell me what is the IYY, please? What's the formula? So this is equal to what? Is this equal to BD cubed over 12? Or is this going to be DB cubed over 12? Anyone? You all can hear me, right? Yeah, yep.
So the one parallel would be cubed to the axis?
Yeah, well done. Okay, so well done. Okay, the one parallel, let me synthesize. Parallel to the axis will be cube. Oh, that is quite dangerous. Wait, yeah, okay, it's quite dangerous. Okay, let me teach you how to identify this. Okay, so anything that is parallel to the axis, right? This direction, we're looking at IYY now. So on the left hand side, I want to focus on IYY. I put down here IYY. On the right hand side is your what? IZZ. Okay. So if we look at IYY, this is our YY axis, and this line I draw is IYY. This will be your width, and perpendicular to the axis, this is your depth. Okay. So let me get rid of this. And then on your IZZ, we're focusing on ZZ now. Okay. So parallel to your ZZ axis will be your width. And then perpendicular. So what do I mean by perpendicular, right? So this is This is the line that is perpendicular to the ZZ axis. So this is your depth. Okay. So you can see it's different now. Yes or no? Right? So you can see it on the IYY, if I project this here, this is perpendicular. So the perpendicular, sorry, this is, what am I doing? So on your IYYC, I'm already confused already. I don't intend to